I can determine the surface area of three-dimensional figures. On your paper, you have a chart that'll make this a little bit easier to fill out, but I'm going to go ahead and fill it out on here, so hopefully you can kind of see it. It's hard to tell in the purple. But the first thing I need to do is to find the area of the top. So depending on how you see this, one of these two is going to be the top, because when you fold it, you're going to end up with different things going on. So I'm going to go ahead and label the length and the width and the height of this thing. So if I'm thinking of folding it so that it looks like this, and if I do that, this is going to be the base right here is 4, and this 2 inches, I'm trying to think, when I fold it up is going to be how tall it is, and this 1 inch is going to be how deep it is. So I'm going to use length times width times height, just so I can keep, not length times width times height, but I'm going to label them length, width, and height. So I'm going to call this my width, I'm going to call this my height, and I'm going to call this part my length. You're going to see why that's important in a little bit. So to find this front face, I'm going to call this the front now. It's 4 inches by 2 inches. And what I've just done is I've taken the length times the height, and that's going to equal 8. Now for the back then, if I call this the front, remember that the opposite sides are the same. So if this is my front, then this is going to have to be my back. So it's going to be the same thing. It's going to be 4 times 2, and that's the length times the height, and it will equal 8. I suppose I need to put my inches squared on here. Now if this is the front and this is the back, I folded it up this way, then this is going to be the bottom, and that's going to be the top. Now, if I'm looking at the bottom and the top, it's going to be the 4 times the 1, so that's my length times my width, and that's going to be 4 inches squared. Now the bottom is going to be opposite it, so if this is my top, that's going to have to be my bottom, because it would be the opposite one when I fold it. So it's going to be the same thing, 4 times 1, which is the length times the width, and it's going to be 4 inches squared. Now finally, I have the left and the right. If I folded it the way I've said I'm going to fold it, then this is my left and this is my right. Now when I multiply these though, I'm going to multiply the height times the width. And it doesn't really matter what order I'm multiplying them in. If I wanted to multiply width times height, that's still going to be the same, 2 times 1. So that's going to be 2 inches squared. And the right is going to be the same thing. It's going to be 2 times 1, which is the height times the width, and 2 inches squared. Now I'm going to have to add it all up. So I have 4 plus 4. These two are going to equal 8. These two are going to equal 16. And these two are going to equal 4. So altogether I have 16 and 4, that's 20, plus 8 more. It's going to be 28 inches squared. Now remember, when I'm finding surface area, I'm adding all the surfaces up. That's why I'm adding and not multiplying these. I'm only multiplying when I'm trying to find just the area of the two. Once I have area, I'm just adding it all up, because I ended up with 4, 4, 8, 8, 2, and 2. We're going to do one more that you have to fill out in the table, and then we'll move to what formula we can use to make this even easier on ourselves. Okay, this time it's already folded, so we have to almost unfold it or think about it like a net. I actually like to use different colors when I do this. Some of you are going to prefer this way, others of you will prefer the net. So it's just going to depend what you like. I'm going to go ahead and call this the front. Maybe that's what you saw as the front, and maybe you didn't. So I'm going to say for the front, and let me label this, I'm going to call this length, and I'm going to call this width, I'm going to call that one height. So if I'm trying to find the front, I'm going to have to take the length times the height, because that's going to give me the area of this. So I have length times height, and that's going to be 15 times 8. I don't know that off the top of my head, so I'm going to multiply it over here. So this is 120 centimeters squared. Your table is set up a little bit differently. You'll just have to fill it in the way that it makes sense in your head. I'm going to go ahead and do the back now because I know something about the front and the back. I know that they're opposite, so I know they're going to be exactly the same. So it's still going to be the length times the height. Even though I can't see it, I know it's back there where I can't see. It's 15 times 8, which is going to be 120 square centimeters. Now I'm going to go ahead and let's do the left. Actually, I'm going to start with the right because I can see the right side. I can't see the left, but I know it's going to be the same as the right. So the right side is going to be over here. I'm going to switch to a different color. Let's go ahead and put it in green. I only have 3 numbers sitting here, but I should have enough for all my sides. If I'm looking at this green shape, its base is going to be 6, our width, and its height is going to be 8. So I'm actually multiplying height times width, and that's going to be 8 times 6. Remember, if I chose to do 6 times 8, it's still going to be the same. It's going to be 48 square centimeters. Now I know that even though that was the right side, the left side is going to be exactly the same. So the height times width is going to be 8 times 6, and that's 48 square centimeters. Now you got to think about what do you have left. So I took the front and the back, I have the left and the right. What else do I have? The top and the side. So I'm going to go ahead and use this blue for my top. Top and bottom. I said top and side, I didn't mean that. There's the top. So the top's a little bit harder to tell what numbers I'm using, but you know you're using this really long side, so if you notice, that's going to be the length. And then you have the depth here. Remember, this is not the 8, because that's not how high it is. That's how far back it goes. So this is going to be the same as 6 centimeters, because this edge and this edge are parallel. So I'm going to use the length times the width. So that's 15 times 6. And I don't know that one either, so I'm going to do that off to the side. So that's going to be 90 square centimeters. And then the bottom I know is the same as the top. So it's going to be length times width, 15 times 6, and 90 square centimeters. Now I found the area of all the sides. When I'm finding surface area, I want to think about wrapping paper again. How much am I going to need to cover the whole thing? So now I just need to add all of this up. So I'm just going to actually add it right here. It's going to be a little bit easier for me. I have 16, 2, 3, 4, 5, 9, 13, 22, 22 and 9 is 31. So 316 centimeters squared. You might want to check my math on that because I did that sort of quickly. I might be off. In fact, I can tell already I'm off. I have these ones over here, so maybe it's 516. I better check that again. So 16, 6, carry my 1. 2, 4, 8, 9, 13, 22, 31, 1. Yeah, 516 centimeters squared. That would be my whole surface area. Now that I've got this thing covered in marker, make sure you get it copied down. Watch it again if you're not sure how I got to those numbers. half this video is just me erasing. Okay? One thing I'm hoping you noticed on the last slide is that everything was doubled. We had the front and the back, and we had that twice. We had the left and the right, we had that twice. We had the top and the bottom, so we had that number twice. So there's this formula. Now, the problem I have with formulas is you're not going to remember this for the rest of your life. I didn't remember this. I just think about it in my head and figure it out. But if you want to, here's the formula. So it's saying 2 times the length times the width, 2 times the length times the height, and 2 times the width times the height, and then you'll have everything you need. So I'm going to go ahead and label these again. I'm going to call this the length. I'm going to call this the width, because that's how deep it is, and I'm going to call this the height. So if I want to use this formula, I have 2 times, and then the length times the width, so 20 and 5. This is just like algebra. I'm now substituting 20 for L and 5 for W. 2 times, now I'm going to put 20 in for L and 9 in for the height. And then I'm going to put 5 in for W and 9 in for the height. Now all I have to do is solve it out. So this isn't too bad. 20 times 5, that's just 100. 20 times 9 is 180. And 5 times 9 is 45. Now remember, if I have a number next to a parenthesis, you can think about distributive property where you have to multiply times everything that's in there, but luckily I only have one thing in there. So I'm just multiplying these two numbers. 2 times 100 is going to be 200. This would be my length times width. Length times width. So this would be the bottom and the top of it, if I thought about it that way. And then 2 times 180 is going to be 360. Since this is my length times my height, this is going to be the front and the back. And then finally the 2 sides would be the last one. So this is 2 times 45, which is 90. So now I just need to add it all up. 200 plus 360 plus 90 is 650. I need a label. Centimeters. Since we're talking about area and not volume, even though we're talking about a 3-dimensional shape, we're only talking about each side individually. We're not talking about all 3 dimensions at the same time. So it's centimeters squared because I'm just talking about area, surface area, not the volume. All right, I think I might have one more practice. I'm not sure. You'll know more than I will because you can see the video, the length of time running at the bottom of the screen to know whether I'm almost done. Oh yeah, just the cube. If you think about the cube, if I wanted to find one of these faces, I'm going to go with this one because my numbers are right there next to me. I have a base of 8 and a height of 8, so this is 64. But the interesting thing about a cube is it's all the same size on all sides. So I can actually just take the 6 faces that we know are on the cube, the front and the back, top and the bottom, left and right, 6 of them, and I can just say it's going to be 6 times, and then my side squared. Interesting, huh? This is the whole formula for a cube, because each side is going to be the same as its height, so the base and the height are going to be the same. So that's 8 times 8, or 8 squared. And it doesn't matter what number I chose. If I had 4s here instead, it would be 4 squared. If I had 12s, it would be 12 squared. So instead, I'm just going to make the algebra part of it easy and say S is going to equal a side. And then whatever I want to put in for S will work. I could figure out the area of any cube. If I wanted to find the area of this one, I would just have 6 times 8 squared. And then I would have 8 squared, well that's 64. Remember your order of operations says you do exponents first. And then I just have 64 times 6, which is 384 centimeters squared, and that was way faster than doing everything else, but it will only work for a cube because all of the sides are the same. And now hopefully you feel really, you can determine the surface area of three-dimensional figures.